Okay, hello grade 12s and welcome to our series of grade 11 review chemistry. The first one we're going to do is we're going to look at two parts. We're going to look at periodic table review and then we're going to look at nomenclature because you need to remember things about the periodic table in order to remember how to name compounds, some of the work you did in grade 10 and then all of grade 11. Okay, so here we go. Periodic table review. Obviously, you need a blank periodic table. It totally doesn't matter what you've got access to, but if you can print a blank one that looks something like this, you'll be able to add your review notes to this periodic table. Think of this as your working periodic table. I want you to summarize information on here in a way that makes sense for you. Okay, have I provided my solution set? Yes, and I'm going to go over some of those things right now. But I really want you to be able to summarize this information effectively because this is the stuff you actually need to know so that you can do all of the chemistry we're going to do for the rest of the course. Okay, so this is what you need to be able to remember from what you learned in chemistry in grade 9 and grade 10 and grade 11 so that you can now have a good working understanding of chemistry. Remember, some of this stuff will be easy for you to go over, and some of it will require a little bit of thinking, right? You got to go back to what you learned in previous years and make sense of this information, okay? This is honestly the basic information that everybody needs to remember. Okay, so here we go with the periodic table. First things first, you remember that the metals are on the left-hand side of the periodic table and the non-metals are on the right-hand side. They're separated by a staircase. And then there are some elements that are amongst the staircase on either side that sometimes act like metals and sometimes act like non-metals, because the closer you get to the middle on the periodic table, the closer you are to transitioning from a non-metal to a metal or a metal to a non-metal, right? There are generally 7 of them, and so which ones are they? Here we go. 1, 2, 3, 4, 5, 6, and sometimes polonium. Sometimes yes, sometimes no. Isn't it interesting when sometimes, elements are so close to being on that border of are they a metal or a non-metal? Well, they have characteristics of potentially both, and so there's still a little bit of debate there. Okay, next thing you want to remember is you want to remember that the group number, these are the things that go down, the columns that go down, tells you how many valence electrons you have. Okay, so elements in group number 1 have 1 valence electron. Elements in group number 2 have 2 valence electrons. We remember that an atom wants to become stable. And when it transfers from an atom to an ion, remember an ion is just a charged atom. So is an ion an atom? Yes, it's an atom with a charge. How do they like to react? They like to react in a way that makes them the most stable. So all of the elements that are in group number 1 will end up with an ionic charge of +1 because that 1 valence electron would like to leave that atom, and that is a trend of the periodic table. Everything in group number 2 will have a 2+ charge. Metals like to lose electrons. They become positive ions, and the term for that is a cation. Okay. Moving all the way over to the non-metal side of the periodic table. You just have to remember, right? Everything in group number 7 has 7 valence electrons. Therefore, it's easier to gain 1 valence electron than it is to lose 7. And so every element that's in group number 7 will have a 1- charge because it will gain 1 electron to become a happy, stable ion. Elements in group number 6 will have 6 valence electrons, -2, -3, ±4, just depending on whether it's a metal or a non-metal. Okay, those are the ionic charges. Remember, you need to know the ionic charges so that then you can figure out how ions come together. And when ions come together, whether it's a metal and a non-metal, then that is where you get the transfer of those electrons to create ionic compounds. Okay, remember we're using the ionic charges, so we have ions and they come together with an electrostatic force that holds those ions together. That is an ionic bond, and ionic bonds are formed between metals and nonmetals forming ionic compounds. They have specific naming rules, they have specific physical and chemical properties, and they're grouped together. Okay? we're going to use the number of valence electrons of our nonmetals when we create our covalent compounds. These are where the electrons are shared. They do not create ions. They just use their valence electrons and share them amongst themselves, right? These are the covalent compounds with shared bonds. And so they have different physical and chemical properties. And of course, the naming rules are different because they can come together in more than one way. That's really important. So you take your information that you know about the electrons for the atoms on the periodic table. You'll then understand whether they're going to create ionic or covalent bonds. And do those electrons get transferred, or do they get shared? And then you'll be able to follow the naming rules as you go. Okay, the other thing you're going to want to remember about the periodic table is you're going to remember the names, the family names, the familiar names, okay? Group number 1 and group number 2 are very similar. You have the alkali metals in group number 1, alkaline earth metals in group number 2. You can remember which is which because alkaline ends in E, earth starts with E, so the one that ends in E is also the one that's the alkaline earth metals, group number 2. You remember that you've got the halogens and the noble gases, and we've got our metalloids on there. Let's now talk about the transition metals. Okay, there are some metals in the middle of the periodic table that can have more than one ionic charge. Okay, these are the ones you need to memorize. Are you ready? There is a number of them, but we're only going to memorize a select list of them. And I'm going to teach you how to memorize them right now. Okay, add these ionic charges to this periodic table, and then the naming rules that we're going to go over will only include these transition metals. But again, are there other transition metals that can have more than one ionic charge? Yes. Do we need to learn everything about chemistry in grade 12 right now? No. So let's learn a manageable number. We'll do the same thing when we learn about our polyatomics. Are there more polyatomics than on our list that we're going to memorize? Yes. Will you always be able to look them up? Yes. So are we going to learn just a few? Yes, we are not learning everything that there is to learn, so we're going to learn a manageable number. All right, ionic charges, these are the ones that are either interesting or you can't figure them out based on the group number because they're in the middle of the periodic table or they have more than one charge. I'm going to go over the memorizing rule. You're going to pause the video, add it to your periodic table, and then give yourself a couple of rounds of memorizing, and then you'll have it. Here we go. We're going to start with silver because it is the number 1 electrical conductor. I remember that, and then I can remember that the ionic charge of silver is +1. Okay, I'm going to go up to zinc. Zinc looks like the number 2. The Z looks like a number 2. It is an ionic charge of +2. Now again, you don't add these ones into the naming rules when you do your nomenclature, but if you can't remember based on the group number, then you have to have a memory trick to help you. So silver is the number 1 electrical conductor. It's got a +1 charge. Zinc is the number 2, and it looks like a Z, and the number 2 look the same, so it's got a +2 charge. Copper is between these two, and it has 2 ionic charges, +1 and +2. Can you see that? It's beside the 1 and the 2. Then I'm going to remember that cross down to the bottom corner where you have mercury, it's the same as copper, +1, +2. Okay? Gold's the one that's different in my little rectangle shape here. It is +1 and +3. All right? Then I'm going to go to iron, Fe, +2, +3. It rhymes, or if you think of the letter F as a capital with 2 sideways sticks and the E as a capital letter with 3 sideways sticks, that can also help you remember that Fe is +2, +3. There are a couple of others on this side that we're going to look at that have more than one ionic charge. These are the ones we're going to memorize. Tin and lead are both in group 4. That's an even number. Their ionic charges are the same, +2, +4, +2, +4. Okay, then we're going to do arsenic and antimony. They're in group number 5, which is an odd number. Their ionic charges are also the same of each other, +3, +5, +3, +5. And that is it. Are there more? Yes. Are these the only ones we're going to memorize this year? Yes. Okay, where do you start? Let's review. Silver is the number 1 electrical conductor. It has an ionic charge of +1. Zinc, the letter Z looks like a 2, a +2 charge. Copper is beside +1 and +2. Its ionic charges are +1, +2. Cross down to mercury, it's also the same, +1, +2. Gold is the one that's different, +1, +3. Iron, Fe, +2, +3. Tin and lead are in an even numbered group. They have the same, +2, +4, +2, +4. And arsenic and antimony are in an odd numbered group, and their ionic charges are +3 and +5. Okay, you practice and you'll have it memorized. Next, let's move on to the diatomics, right? There are some nonmetals that when they come together, they create diatomics, and I bet you know the acronym for this. Do you remember? Hofbrinkel. They also form the number 7 on the periodic table, and there are 7 of them. So we use whatever memory trick you like. 1, 2, 3, 4, 5, 6. Where's the 7th? Hydrogen, right? So they make it a little number 7, and they also follow the acronym Hofbrinkel. You need to remember that at the gaseous state, at normal room temperature, they're gases, and they will always come together in a molecule that has 2 atoms covalently bonded together. All right, what's next? I'm going to go right now to my summary sheet, which is right here. And again, I've posted this in D2L, but I just want you to note that, again, you're going to be doing your own notes, okay? You can use this as a header, or, what categories are you going to think about when you're adding to your periodic table, but I do want you to make your own notes, all right? I can see that we are going to look at electron configuration, so don't forget where your S block on the periodic table is, the P block, okay, the D block, and your F block, and you remember that D lags behind 1. Remember, this is for how you do electron configuration. We're going to review that in another review video, but add it to your periodic table because it is something that goes along with that information that you want to have at your fingertips in case you need to review. All right, we've already talked about making ionic compounds. We've talked about making covalent compounds. We have 2 full days of reviewing different kinds of aggregates and talking about intramolecular bonds and intermolecular bonds, but remember that they are grouped separate because of the kinds of atoms that make up those compounds. We follow different naming rules, and they have different physical and chemical properties. Okay, let's move on. Next thing you learned in grade 11, you spent quite a bit of time with, I would guess, on your trends of the periodic table. And you need to remember that the atomic radius is connected to the ionization energy, which is connected to how elements react, okay? You need to memorize these. You need to be very familiar with them because this is how you explain things at the molecular level. All right, we need to be able to explain, well, why is it more reactive? Why is the bond between things stronger or weaker when you add it to a different compound? Okay, as the atomic radius, and I can go over a couple of these quickly with you. Okay, this is the distance between the protons and the outermost electrons. So clearly, as you go down the periodic table, every time you're adding an energy level, you are increasing the radius. So that's a nice easy one, right? Explain that. Why? Well, you're adding more electrons, right? Francium has 87 electrons. Those electrons are in 7 energy levels. So that radius of the atom is much bigger as you go from hydrogen all the way down to something that has 7 energy levels occupied. Okay? As you go across the periodic table, this is the one that you need to remember that, yes, you're adding electrons, but those electrons, as you move across the periodic table, are being added to the same energy level. So even though you're adding a proton, the charge difference between the proton in the nucleus of that atom and the electrons pulls them in tighter. And so as you move across a period, you are adding electrons to the same energy level, and the radius will get smaller. Okay, now how does that relate to ionization energy, right? So ionization energy, these two are linked. The amount of energy required to remove an electron, Okay, so here we go. As you move down the periodic table, less energy is required. Why? Because the electrons are further away. They have a greater radius, therefore they're held together with a smaller amount of force. That means those electrons are easier to leave. It is easier for them to leave. It is easier for them to react. Okay, pause the video, go over that in your head. Could you explain that to somebody else? As you move across the periods on the periodic table, so as you move across a row, the ionization energy increases. Why? Because the radius decreases, which means those electrons are held closer and tighter together. Therefore, to remove an electron, which is what an ionization energy is, it becomes higher. It requires more energy because those electrons are held tighter. Now you explain, okay? So go, make your summary note, explain this, and then you can watch the rest of our summary periodic table video. Okay, now we've moved on to a couple of other things we're going to go over. Of course, you want to remember the gas tests. That's basic chemistry from grade 9 and grade 10. So remember what the testing is for oxygen gas, hydrogen gas, and carbon dioxide gas. Solubility rules, you learned that in grade 11, and we are going to review that probably in every unit. So why don't you memorize those right now? Anything that's in group 1 or group 7 have good solubility. What's your example? Sodium chloride, right? Make it simple and then remember the rule based on your example. What are the other polyatomics there with good solubility? You can memorize those, please. Okay, next we need to come up with a rule when we calculate the molar mass, and you have to promise me that this is the rule we're going to use. Why? Because we want our calculations this year to be the same. Please take your atomic mass from the periodic table to one decimal place. Follow the rounding rules, round it properly, and then you need to show all of your work. So remember, if you were calculating the molar mass of that example right there is carbon dioxide, you have to write it down as 12.0 times 1. There's 1 carbon. You cannot drop the 0. A number of 12 is very different from a number that's 12.0. Okay, this is chemistry. You need to be specific, and if you like chemistry, you like to be detailed and specific. A 0 means a 0. It doesn't mean that it was 1, 2, 3, or 9. So if it is 0, you write a 0 because it means that it was a 0. Okay, you will lose marks every single time, so please don't drop that. Follow the rules. Okay. Your answer then is 44.0 grams per mole. There's an example of how to show all your work for calculating the molar mass. All right, if you needed the more trends, the summary of that, I put them on the back of this diagram so you can see as I just went through and summarized, I jotted down what are the things that we need to remember. There's a few others there about strongest polars of electrons, and by all means jot that down as well. Okay. Next, part 2, we're going to be looking at our nomenclature, okay? So in your notes, here's where we actually start working on grade 12 stuff, but again, we're still working on review. This is in package number 1. You want to go over your nomenclature concept map, and you want to go over that in detail so you can add some highlighting and add some colors to it. You want to be able to use that, know what the rules are, and then do a review on this page. So page number 5 is what you're going to be going over with nomenclature. All right, what did you learn in grade 11 and what do you remember? Here's your concept map. I've printed a copy for everybody. You're going to want to be familiar with what you did in grade 11, okay? And let me help you navigate this a little bit. First, you're going to start with here, okay? We start with the group. The number 1 just refers to this as one type of naming rule that we have. Okay, this is where we have an ionic compound, and we know that an ionic compound is made up of a metal and a non-metal. How do you remember? You simply look at your periodic table, right? I would tell the grade 10s that. Just find them on the periodic table. If the compound is made up of a metal and a non-metal, then it's ionic, and then you follow this rule for naming. Is it a metal with only one oxidation number? Then these are the easy ones. Okay, you take the metal name and you take the non-metal, or whether it's a polyatomic, and if it's non-metal only, then you add an IDE. Do you remember that? Sodium oxide, zinc phosphide, beryllium phosphate. Okay, Polyatomics, where are they and which ones do we need to memorize? They're on the back page. And here's your list of polyatomics that you want to memorize. Memorize them in this order because there's a method to this madness here, right? We've got one that's got a +1 charge, that's ammonium. Then we're dealing with the ones with a 1- charge. We're going to look at the ones with a -2 charge and then a -3 charge. You'll notice that sometimes I talk about ionic charge and oxidation number interchangeably. We'll get through the nitty-gritty of all that when we get to unit number 2. Okay, because we're going to look at what's the difference between the ionic charge and the oxidation number. But as far as we're talking about nomenclature, any ionic compound, the metal's ionic charge is the oxidation number. So I can use those terms interchangeably, no problem right away. Okay, so that's where you're going to memorize it. If you don't memorize it yet, you need to know where that is. Okay, next. We've got our metal with more than one oxidation number, and you remember that there are 2 systems for this. There's the classic system and the stock system. So that's there's a bit of a memory table you can work on for that, and you will need to be familiar with both. So whether it's ferric oxide and iron 3 oxide, can I highlight a couple of things here with regards to conventions as you're writing? Don't forget that we're specific in chemistry, so you always start with lowercase letters for your metal and your nonmetal. There is a space obviously between your metal and your nonmetal, but notice there is no space between the transition metals. So if there is more than one number, you put the Roman numerals there. No space between iron and the brackets. Okay, can you review some of these? Why don't you go over a couple of these that are on this practice page here? And of course, you want to transfer the information about the classic stem name. And these are ones we've memorized, those oxidation numbers. We've just gone over that. Okay, so that you can transfer over to page number 5 as your review. Next, this is the easy one. It's just ionic, but if there's a hydrate. Okay, and again, just notice how that looks. Right? Copper 2 sulfate pentahydrate is as if you've got 1 copper sulfate bonded with 5 waters around it. That's what that would look like, okay? So it may have been a tricky one, but if you need to practice counting up all of the atoms that are in one compound of copper 2 sulfate pentahydrate, break it all down and practice your numbering of all of the compounds. So you could add them up if you need to, because of course, where do we use that? It's when we do our balancing chemical equations. Okay. Next, that takes care of all the things on the top part, which are the ionic compounds. And then, of course, we need to look at what if you've got a molecular compound, and these are the ones where you've got a metal and a non-metal. Okay? Sorry, non-metal and non-metal together, molecular compounds, covalent bonded, sharing of the electrons. They follow completely different naming rules. Why? Because opposite of the ionic compounds, which come together in predictable ratios, always the same, the molecular compounds can come together in different ways. And so when atoms can come together in different ways, you need to have a rule for how to name compounds where that's the case. Okay, so here are some of the rules. Remember, if it's an inorganic compound, you put a prefix in front and then a prefix in the nonmetal and you add IDE. Of course, we don't add a mono in front, and then if there's a mono oxide, you always drop one of the vowels. So there's your rules for how to drop the vowels if you need to. Do you remember the prefixes? Okay, mono, di, tri, tetra, penta. Take a minute and memorize those. I'll tell you that if any of them that people mix up on or they make a mistake on, it's number 6 and number 7. And I don't know why, but 6 is hex. There's an X in hex and an X in 6. And 7 in French is sept. And that reminds me that it's hepta. That helps me. Maybe that'll help you. All right, some more practice. Go for it here if you'd like. Take the compound, do the naming, take the name, write the compound. Again, lots of nomenclature practice that you could work through. Now, how do you change the number of the number of oxygens. Let's get to that in just a second, but remember your formula for your organic compounds. Monkeys eat peeled bananas. Do you remember that one? Okay, and the general formula is CnH2n plus 2. So work your way through those. Recognize them as that standard CnHn H2n plus 2. And then, of course, if the number of oxygens change, then that's where you're going to follow the next rule, which is over here. Okay, and these are variations of oxygen. All right, if you have more than one oxygen, you take your starting point and then you add a per in front. One less oxygen is ite. Hypoite is two less. Ite is lower than eights. I is lower than an A. There's a couple of memory tricks you can do for that, okay? But you want to be familiar with those as well. All right, and the last bit on here are the hydrogen compounds. So when hydrogen comes together, remember, if the hydrogen comes first or if the hydrogen comes second, hydrogen's either acting like a +1 charge or a -1 charge, and it just depends on where it comes in the formula, okay? It acts like a +1 when it's with your non-metal. When it's with the metal, it'll act like a -1, and then you follow the naming rules based on that. Okay, I'm going to give you time to work on those when you do your nomenclature review. I guess we could do one more thing where we talk about the acids. Let's do this part and then I'll stop the video. Okay, now on the bottom here, you've got your polyatomics memorized. Okay, you know the charges of the polyatomics. So at the bottom of the page here, this is all you need to memorize. Once you know that, you can easily tell what the acid name is going to be because the acid has just hydrogens added in, and hydrogen is a +1 charge. So if you've got a polyatomic with a -1 charge, clearly it's going to have only one hydrogen with it. If it's a polyatomic with a -2 charge, then it's going to have two hydrogens with it. And that is really important. You want to know that you know how to do that. Okay? And again, if you've got your polyatomic ions and the charges memorized, you can easily see how many hydrogens come together. Okay, so here we go. What's your starting point? Oxy acid. This is an acid with oxygen in it. Nitric acid will be nitrate with the hydrogen. You show it as aqueous. That means it's in a solution. That's our acid. Okay, chloric acid, chlorate, had only a 1- charge, so chloric acid, and they all end in X. That's our starting point, oxyacids. It will also just be HClO3, aqueous, right? That tells me it's chloric acid. So you need to look at the state in order to remember that. And then if you go all the way down, you don't need to memorize phosphoric acid is an H3PO4 aqueous because you memorize that a phosphate is a PO4 with a 3- charge. Therefore, when it combines with oxygen or with hydrogen, you're going to need 3 hydrogens. So phosphoric acid will be H3PO4. See how you're going to use those memory tricks? You take the charge of the polyatomics, you add how many hydrogens you've got. That's your starting point for that oxy acid. And then if you look at the number of oxygens in that compound, if they go up by 1 or down by 1 or 2, then you just change the prefixes and suffixes of it. So again, chlorate was here, so chloric acid is here. Perchloric acid would be ClO4, and chlorite would be HClO2, and hypochlorite would be HClO. So when you're changing, you're just changing the oxygens. Okay, that's a lot for now. Periodic table review, nomenclature review. Good luck. Let me know how it goes.